Devikan here with another question from topic 2.2 from the question bank. In this question, we're asked about a graph below which shows the variation with time of the velocity of an object moving in a straight line. Using this graph, we're asked to find the displacement of the object from 0 to 6 seconds. Now we know from transformations of graphs that if we want to move between velocity to acceleration or velocity to displacement, we want to look at either slopes or areas. And the tricky part is remembering which. But we know in this graph we have velocity on the x-axis, on the y-axis, that's meters per second. And we have time on the x-axis, that's seconds. And we want to produce displacement, that's meters. So how do I get meters per second and seconds to interact and produce meters? I have to multiply them. If I multiply those two, seconds and per seconds cancel out, and that leaves me meters. That's my clue, right here, multiplication. Because if I multiply a height by a width, that produces an area. So what I'm looking at is two areas. The area here, below the curve, and the area here, above the curve. Because the object is actually doing two different things. In this region, its velocity is positive and decreasing. It's going forwards but slowing down until the 4th second when its velocity reaches 0. At this point, its velocity becomes negative and starts growing, so it's reversed direction and started returning back. So the final velocity is going to be the blue region, take away the green region. Or in other words, the total displacement is going to be the blue region, which is 1/2 base. The base is 4 seconds. Times height. The height is 8 meters per second. Take away the green region. That's 1/2 base times height. This base is 2 seconds, and this height is 4 meters per second. Now you might argue, oh, well, it's negative 4 meters per second, and that's a fair argument. But if we're talking about areas, we just want the magnitude of this area, so we'll leave it as positive, and we'll take it away from the whole. So 1/2 base times height. This gives us 16. Take away 4. That's 12 meters. So that'll be